Hello, everyone. Thanks so much for joining the Wednesday lunch break session. My name is Doc V. I'm a meteorological scientist at the Weather Company. And I just want to be clear that the views of this stream does not reflect those of my employer, but are meant for educational purposes. And we are watching another impact here in the tropics, another landfalling hurricane. This is Hurricane Sally, just made landfall hours ago across the Gulf shores of Alabama. Now I want to read off a list of names here, guys. Bertha, Cristobal, Faye, Hannah, Isaias, Laura, Marco, and now Sally. I'll say that one more time. Bertha, Cristobal, Faye, Hannah, Isaias, Laura, Marco, and now Sally. These are the 8 tropical cyclones that have landfalled across the United States of America this 2020 season. To date, that is a record high number of storms making landfall until September 16th. It has been a remarkable season, and we are one more storm away from a landfall to tying the all-time record number of storms to landfall across the U.S., which was set way back in 1916. Guys, it has been quite a journey this season. It has been ridiculous, the amount of activity that has happened over the course of just a couple of months here. We are at 20 named storms, guys. We are one storm away from the Greek alphabet, right? We just have Wilfred left in the cards, and that's it. So this is a radar image right now of Sally. You can see how there's a ton of heavy precipitation pushing slowly to the northeast here. A lot of distinct rain bands associated with this and very heavy rains. There's a lot of flooding going on in parts of the Gulf Shores and in the Panhandle of Florida. There's been a confirmed tornado already. These are all things that we're going to get to here in the coming hour. So I just want to stop and move into the just chatting screen here. Thanks for everyone joining here. I appreciate it. These Twitch streams are something that I've been playing around with for, the start of the hurricane season. Last week we had some serious lag. I'm hoping that this week has been better. I've moved over my platform to OBS, so if there's any lag issues, guys, please let me know in the chat, and I will try my best to overcome them. Again, for anyone new on with Twitch, because this is something new for me, if you want to be able to participate in the chat, all you need to do is follow me on Twitch, and then you'll have access to kind of just go in there in the chat and talk. For those who are subscribers, I appreciate that, guys, very much. The goal here is to get enough subscriptions throughout the upcoming year or so to be able to get new hardware to make these streams better for you all. That's all. So again, thanks so much here, and I appreciate it. So let's get back into some of the action. I see there's some guys in the chat. I appreciate guys stopping by again. It has been a very interesting year so far. We've seen 20 named tropical cyclones over the Atlantic Basin, 8 of which have landfalled across the continental U.S. during a year of global pandemic, during a year where massive forest fires have broken out in the western U.S. and has ejected a ton of smoke and particles into the atmosphere across the northern tier of the U.S. It's actually blocking parts of the sun for me here in Boston, Massachusetts. That's where I live. It's been just crazy weather-wise. It's been crazy, just a year in life. It feels like we're living on a different planet. And if you're literally in the Pacific Northwest, you feel like you're living on Mars based off of some of the imagery that we've been seeing over the last few days, last week or so. So it's been crazy, guys. Let's move into some of the nerdy out science things here. We'll get back to the screen share here and kind of move forward. Let's take a look at the latest satellite loop of Hurricane Sally as it has made landfall and is currently pushing inland now. It's probably about 20 miles inland from the Pensacola coast there, but we see that there's been a ton of deep convection. There was an eye that popped out for a period of time prior to landfall. The storm actually intensified back into a Category 2 hurricane prior to landfall. There's some good imagery that I'll share here that some folks have been sharing on social media to kind of take a look at the dynamics and the structure as this storm intensified as it moved into the coast. And we'll look at some of the impacts. These storms are we watch these storms as meteorologists on satellite It's unbelievable to see them on satellite, but then when you see the impacts, that's where it really hits home, right? We don't want to see impacts from these storms. I'd rather have 17 Category 5 hurricanes out over the main development region and not impact any land than seeing one Category 2 landfall in the U.S. because it's just difficult. Think about all the economic impacts this is going to have here, especially during a year where our economy has been critical. It's been we've had a major blow due to the COVID outbreak, and now we've seen not one, not two, not up to 7, but 8 landfalling storms. It's just been absolutely insane. So right now we're looking at an infrared imagery of Hurricane Laura as it tracks inland. It has weakened. These tropical cyclones will weaken as the circulations move over land and interact with the land. We call this, when these tropical cyclones move over land, there's elevated friction generated by the land, and that can interact with the circulation of these hurricanes. And on 95% of the time, as a tropical cyclone moves over land, it's going to weaken. There are some rare circumstances where hurricanes or tropical cyclones can move over land and continue to intensify. This is called the brown ocean effect, essentially, where if the land is very moist underneath and it's been pretty warm down in that part of the world, any world wherever it is, you can get actually some interaction between the water on the land surface and the tropical cyclone that can still cause some intensification. Dr. Marshall Shepard has done some work on this and shared that on social media that you guys can refer to if you have any more interested in that. But let's take a look at the National Hurricane Center. It is currently a 85 knot storm, which is 100 mile per hour sustained winds. Now I suspect this will come down here pretty rapidly over the next few hours. The min sea level pressure was 967 millibars at the time of observations. That is a healthy tropical cyclone, lower grade Category 2 hurricane, but still strong. And it's moving very slowly towards the northeast at around 3 knots. We can take a look at the National Hurricane Center track prediction cone here, and we can see that the storm is generally predicted to drift off to the northeast across Alabama, weaken into a tropical depression as it moves over eastern Alabama, and continue as a tropical depression as it pushes across north central Georgia there into South Carolina, where the storm is expected to weaken and become a post-tropical system. Now, during these very slow progressive storms, the biggest threat here, in addition to rain and storm surge, is rainfall. When we see these storms barely move, it can essentially keep these intense rain bands over a particular location for a prolonged period of time. And that can really cause devastating floods. And it actually helps to enhance your storm surge too, as it slowly drifts on, because you get these south to northerly enhanced winds for a prolonged period of time, and that pushes a lot of water on shore. And there's been a tremendous amount of storm surge already observed with this storm, especially in the Pensacola Beach area. I think this, according to a tweet by Jim Cantori, which I'll show here, this was the 3rd highest storm surge on record for Pensacola. So Sally is by no means a weak tropical cyclone, and there are going to be economic impacts from this storm. So let's take a look at some of the impacts here. One tweet I want to point you guys to is by Mark Sudduth, a hurricane chaser, and this was a picture of flooding in I'm sorry, it's actually storm surge or tidal surge flooding for a place called Perdido River. And this is essentially showing where we are today, right now, around 14 feet, and essentially where the storm surge is predicted to go. And it's predicted to go at 27 feet, guys. That is ridiculous. I mean, we're talking about major flood levels here for this particular river basin. And he actually put a video of I think it's of a webcam of what it looks like before the storm surge hit and what it's looking at right now. And just keep in mind, this location still hasn't achieved peak storm surge, right, or peak flood levels. So this is what it is before those flooding, the storm surge pushed in, and this is what it looks like now. And again, keep in mind that isn't even peak surge, guys. This is literally where we still have 10 more feet to go. So this is going to be completely submerged. It's already submerged underwater. This is like absolutely insane, guys. Hey, Budget, I see that you have a question here. What economic sectors do you feel have the biggest crossover with COVID and storms? I don't see a correlation. Well, when I was referring to the economy, right, we've seen a pretty big dent in the 2020 economy from a lot of companies closing their doors for a period of time. We've seen a lot of the gyms, et cetera, shut down. It might not be everywhere in the U.S., but a good portion amount, especially in the Northeast, things have shut down. And this has caused hurt and stress on our economy. If you add in 8 tropical cyclone landfalls, it's only going to make that economy more hurt, right? You're only going to add fuel to the fire here, right? It's not a good situation. Our last landfalling hurricane, Major Hurricane Laura, when that landfall, I think that cost over $8 billion. Like that's a huge economic staple. That's a big dent in the economy there. So we are trying really hard here to kind of get past this year that was featured in a pandemic and caused already stress on our economy. And now we have these hurricanes to deal with. So I appreciate the question and thanks guys for joining there. I see Tim and some other guys, King, you're in the chat. What's up, guys? How you doing? So let's take a look at some of the other interesting things here. This is downtown Pensacola. I will zoom in here. It looks a little laggy here, but you can see how storm surge has devastated parts of Pensacola here. That is a pretty large SUV underwater there. It's actually, I'm blocking it. So let me see if I can move me out of the way here and put me down. You can see that it's just a tremendous amount of storm surge across. This looks like a Main Street area. And you can see that water is probably a good 2 to 3 feet on the base of the surface, on the bases of these buildings here. You can see how the police are out there trying to help out, man. My brother was, when he was working out in the Sandy, when Sandy made landfall across parts of the Rockaway beaches, the police couldn't really do a whole lot, right? These guys they don't have boats. There are a number of boats that can go in and help save people. There obviously are relief efforts, but it caused these types of flooding events can really cause stress on rescuing folks. And police are pretty limited when they have such impacts like this that can really cause headaches and folks that can be in danger, right? Your property and life. So let me zoom out here and take a look at some of other things here. Here's the tweet from Jim Cantori, the 3rd highest storm surge on record in Pensacola. Let me mute that there and show that how things have shaped out in the Pensacola area. Not the best quality when you zoom in, but you can see how just a tremendous amount of water on the ground and up against buildings here. This is no joke, guys. This has been a tremendous impact here for Pensacola, as well as other parts of the Gulf Shores, Alabama. If you guys ever want a really beautiful location and check out the Gulf Shores, I was able to spend a week down there. It's just beautiful. So one other thing that I want to point out here, which is pretty darn interesting here. Back on September 16th, 2004, Hurricane Ivan made landfall across the Gulf Shores, Alabama. Today is September 16th. It's 2020. So we're 12 years later, right? 16 years later. And we are in a similar situation with another Category 2 landfalling hurricane in the similar location, looking at a very similar structure to these storms. This is just by chance, right? This is not something that we would expect to happen, an anniversary here that we have the same type of landfalling, but these are the things that can randomly happen in the tropics. And it's quite remarkable how things have just evolved so similarly when we look at Ivan and we look at Sally, right? So Ivan was a very impactful hurricane landfall. Sally, another very impactful hurricane at landfall. So one thing else that is happening here, if you look at the Storm Prediction Center, this is essentially the government agency that issues where severe thunderstorms will be around the U.S. at any point. You can see that this NOAA's Storm Prediction Center has predicted a slight chance of severe thunderstorms across the Panhandle of Florida into southeastern Alabama and into Georgia. This is not due to random chance because these hurricane landfalls do or can generate brief tornadic spin-ups. We've already seen a confirmed tornado in the vicinity of the Florida Panhandle, and we're expecting the risk for that to continue here in the coming 24 to 48 hours. Now, the reason why these hurricanes can generate tornadoes is as a rainfall band. I can go back to our rainfall band image here this is from Brian McNulty's page. And you get these really deep embedded convective cells, linear oriented. And a lot of these times when these bands, these precipitation bands, we call these outer rain bands of hurricanes, move over land, it can actually generate friction that then can spin up these brief tornadic cells that can produce short-lived tornadoes. Now, these are usually like EFOs or EF1s, but nothing like we see out in the plains during severe weather season. But it's just another headache here for folks that have to deal with these heavy rain events, and you can get these really isolated locations that can experience these brief tornadic spin-ups that can actually cause these winds to kind of exceed expectations at a particular location where that in the vicinity of those tornadoes. So. So that is something that the Storm Prediction Center is monitoring. We can go over to the tornado risk plot, and you can see how they have a 5% chance of we move this actually out of it. I'm actually going to take off this stream chat here, guys, or minimize it to get it out of the way so we can see what I'm talking about. I apologize for those watching. You can't really see behind it. We do have a 5% chance of tornadic activity across a lot of the Gulf Southeast into Georgia. So people who are in the track of this tropical cyclone, you guys are going to have to pay attention here to this event here, because there are the chance of tornadoes that can happen from these outer rain bands as this tropical cyclone Hurricane Sally pushes to the south, to the north and northeast. I want to show a simulation from our 4-kilometer graph model here. And essentially, this is a model that IBM has been working on, specifically the weather company. And I was given the green light to start sharing some of these graphics because they're beautiful and they're just such a pretty looking graphic here. This is the upcoming forecast. We run this out 72 hours at 4-kilometer resolution. And this is the forecast here for what we can expect with Hurricane Sally as it pushes towards the north and northeast at a very 3 to 5 miles per hour. You can see how the heavy rain continues to fall across portions of Alabama out for the next 24 hours. And that heavy rain eventually slides northeastward as the storm starts to weaken and gain a little bit more forward momentum out to sea. But this is a tremendous amount of rainfall that's predicted to fall over the next 24 to 48 hours across parts of the southeast and continuing up to the Carolinas. We're expecting heavy rain. And if you want to see how much actually rain falls from this particular simulation here, we're looking at locations could pick up exceeding 15 inches of rain here for parts of the Florida Panhandle, guys. So in addition to dealing with storm surge, you're going to have to deal with a ton of rain that's going to be falling from the sky due to these heavy rain bands that are just sitting overhead. Now, as that storm moves out to sea to the north and northeast, you can see the track of Hurricane Sally in these enhanced precipitation totals, right? We're looking at inland Georgia to see near 5 inches of rain as it moves up into the Carolinas. You'll see a lot of widespread 2 to 6 inch rain totals here. So, guys, it's a ton of rain here that's predicted as Sally moves up into the northeast. And this was well predicted and well handled by a lot of the government agencies that are dealing with issuing warnings for these types of events. And they're doing that to protect your life and property, right? We're talking about the National Hurricane Center. We're talking about the CPC, the SPC. These are all experts in the field that are particularly geared to handle a lot of these types of events, and they're monitoring them 24/7. I was able to visit some of these facilities, and the professionalism that these and skill of these guys, you can't beat them. All right. So, but this is just a very tremendous, a huge swath of heavy rain that's predicted to fall across a lot of the southeast here in the coming days. Again, this is the total precipitation field that's predicted by the 4-kilometer graph model. This is an IBM proprietary model. We don't have these graphics available for the public, but I'm free to show these on these Twitch streams here. so you guys can take a look at them. And we also provide the forecast information on the Weather Channel consumer app on your iPhone or Android, as well as weather.com. Again, the views of this stream does not reflect those of my employer, but we're here just to kind of educate you guys, right? If you want more information about these models, check out those sources, guys. So Sally is still going to be a problem here over the next 48 to 72 hours for the U.S. It's going to slowly drift out to sea and move out of the window. There are some other things that we have to pay attention to as we move forward into the tropical season. But if anyone wants to ask any questions here on the stream about any impacts with Sally as you know, over the next 24 to 48 hours, feel free to ask now, guys. Okay. And yes, Pensacola is going to be in rough shape. It already is, guys. I mean, we can bring up some more imagery out of the Pensacola and the Gulf Shores regions. I mean, here's another shot from Pensacola. Look at that, guys. That is not what you want to see if you're a homeowner in Pensacola, right? Just a tremendous amount of flooding across a lot of the Panhandle of Florida, the Gulf Shores, Pensacola Beach. Very sad to see this happen. All right. Oh, budget. Okay, I see you got a question here, bud. What about Chesapeake Bay area over the weekend? Will the storm track over the eastern states? Yeah, so if we head back to the 4 kilometer graph model, you can see how there is heavy rain moving into the Pensacola region. It looks like the heaviest rain in the precipitation shield will end up being a little bit further south, but there's still going to be impacts in that region. Have you guys ever experienced a landfalling storm that's, pushing storm surge and producing a lot of convection? Have you ever gone across the Chesapeake Bay area, that bridge specifically? It's ridiculous. I remember when there was a particular hurricane. I'm trying to remember which one it was. But I remember when I was vacationing one summer out in the Outer Banks of Carolina, and beautiful area. If you guys ever want a really, amazing beach vacation, go check out OBX. Just a fantastic area. But I remember we were evacuated actually out of the area because our vacation was cut short by a landfalling storm. I lived up in the Northeast in University at Albany at the time when I was in grad school there, so I had to drive up the I-95 corridor. So I decided to take the Chesapeake Bay Bridge. Wow! If you ever want to see a cool experience and scary experience, take a drive down the best Chesapeake Bay Bridge before landfalling a hurricane. If there's any impacts and storms out there, because you could just see how the elevated water creeps up there, and you see it, you go in and out of this bridge essentially. That if there's thunderstorms in there, you come out and it looks like a massive storm about to hit, and you get a lot of rain and wind, and the storm surge is really high, and then you go back underneath and it's calm, and you come back out again. It's just a crazy experience. So if there is a hurricane landfalling, definitely don't go out on the bridge, because you might get trapped out there. I'm sure they have safety measures out there where they won't allow you on the bridge if conditions get too bad. But if you get right in that sweet spot timing wise, and you want to see a crazy storm going in and out of a bridge driving across the Chesapeake Bay, it's a crazy experience. So Manifest, thanks for joining the stream, bud. I think it's interesting to see how the model forecast compares to MRMS after it passes. Yep, I think so too. It's I always like to look at this 4 kilometer graph model. It's one of my favorite models to look at because of the resolution, and it's obviously it hits home to my heart because my company's outputting this model. Kim Miller from the Post, thanks for joining. I appreciate it. You came in a little bit late here, so can we talk about why Sally strengthened at the coast? You would have thought cooler waters would have been pulled up because it was moving so slow. Thanks for the question, Kim. I know you've been asking this question a lot, and that we can try to take a look at here of what happened with Sally. I'm gonna try to bring up a new window here. Let me pause some things out here so I don't have to lag out like I typically do. I'm going to go to Levi Cohen's page, Tropical Tidbits here. and look at the ocean temperatures from his analysis tools. And specifically look at the Northeast. We'll look at the Western Atlantic, right? That's the tropical Atlantic. It's my first day driving the bus here. Yeah, so as you can see already that there is a signature of upwelling, right? We can see how there's been a 7-day change in ocean temperatures. Ocean temperature anomalies are actually slightly below normal now across the northeastern part of the Gulf of Mexico basin. And if we look at actual temperatures, right? Let me take a western look here. These ocean temperatures are still around 28 to 29 degrees Celsius. Those are still warm enough to support intensification of tropical cyclones. Now, obviously, ocean temperatures of 30 degrees Celsius are ideal for like Category 5 intensity, but as the storm moves inland, it's still able to absorb this energy from the ocean as it moves inland. And we're actually looking at a response, right, to the actual hurricane passing by. It absorbs that warm water out of the ocean. It takes in those radiative fluxes from the ocean to the atmosphere, and this is one process that fuels hurricane intensification. I haven't seen high resolution ocean temperatures to see, as the storm moves, how quickly things change. There may be some sort of lag where, we see this upwelling continuing for a period of time after the trop cyclone moves out of the area. And that could be why we're seeing such a pronounced footprint in ocean temperatures as Hurricane Sally has moved out of that area and into land. But I remember looking at some of the things like vertical wind shear, and I can bring up a page that actually brings up a lot of information that you can get out of the ship's model. And this is the RAL tropical page. And you can just click over to the ship's diagnostic message and see what the message was showing here and what parameters were important. And I think I want to show some things here about shear, right? Shear was pretty high now. This was actually taken at 12 UTC, so we're already out of the time frame. But there was a period of time where this particular tropical cyclone was able to adjust into its environment, even though it was absorbing water from, it was changing temperatures, allowing that upwelling to start to take place. It was still at a point where the storm was absorbing energy from the ocean, and I think it was moved into a slightly more favorable environment. There's these things called good shear cases and bad shear cases for intensifying hurricanes, and it's still hard to kind of understand when we're going to see a good shear event happen where shear can actually help a tropical cyclone intensify, and there's it's compared to one of these events where there's too much shear that essentially just tips over the convection and causes these things to break down. But this particular event, we did see that the intensification still happened, and we can actually look at the dynamics. I did retweet someone here that I want to find out, Tom Berger, that produced an image here that I thought was really interesting that showed the track or the inner dynamics of this particular system. Here we go. Tom Berg he was a UAlbany guy, and this takes a look at essentially microwave imagery here that can actually look at the potential convective burst that led to the quick intensification right before landfall. And you can see that these are wind speeds essentially in the shading and mean sea level pressure in contours. And you can see how this particular storm really intensified as it moved right into land. So it wasn't actually over that part of the Gulf of Mexico with a very shallow thermocline, meaning like it can pretty much mix out cold water to the surface pretty quickly. It wasn't really stable over that ocean part for a long period of time. It actually moved inland as it kind of intensified right before land. You kind of see a little bit faster forward speed and forward jogging speed there as it moved in. So these are great questions, though, Kim. My PhD is in tropical meteorology, but it's more into like looking at equatorial waves. I'm not a hurricane dynamics specialist. I would recommend reaching out to some of the experts in the field. And I can if you want to reach out a little bit later, we could do a direct message on Twitter. I can point you into some folks to ask that question to specifically. So Manifest, I see your question on the graph model again here. So the model is the graphics that I'm showing on these pages here, right? These types of particular graphics. These are not available to the public. These are internal right now. But if you want to look at forecast information from the graph model, the 3-kilometer resolution specifically, if you go to your Weather Channel iPhone or Android app or the weather.com platform and look at radar reflectivity in the future sense, that is coming from our 3-kilometer graph model. So that's where you can actually see the precipitation forecast in a visual content. Crazy ecologist. I appreciate you coming on, man. First time here. Okay, so what is your thoughts on Teddy? The guidance is shifting further west, Bermuda, New England. Also, what's the threat of 98L to Lesser Antilles? Okay, let's move on the discussion to the future, right? Let's move on to focusing on what storms are coming. And one way to do that is looking at these ensemble plots by the Weather Nerd page. I love this stuff. I mean, actually, let me get a little bit smaller here so you guys can see the entire map here. But so this is a loop of the ECMWF ensemble model. It's essentially a simulation that's run 51 times. And all the guys are doing here in this model is tweaking the initial conditions to see where the variance in the forecast lies. You know, by tweaking the initial conditions, you can essentially add errors into your forecast that might be due to bad sampling of observations. And you can see how that changes the forecast downstream. And that's what we look at when we look at these ensemble models. And we can think of these things as like spaghetti models as well. But I'm going to loop this. This is a cool image here. And you can see how the models will diverge as they move out in time with the tracks of these systems. So this is Teddy right now, right? And you can see how the models are predicting Teddy to intensify into a healthy major hurricane. We're looking at a Category 3 or Category 4 hurricane as it pushes up across the western side of the Mid-Atlantic Ridge. And it takes more of this northwesterly track as it kind of sneaks in on the west side of that periphery of that Mid-Atlantic Ridge. And that's this is something that's evolving with time here. We're seeing some shifts in the models. I think, though, this storm is probably going to stay, east of the continental U.S. and it probably has a better chance of impacting like the maritime provinces out there in eastern Canada. But there's still a non-zero chance of some impacts in the Northeast. I mean, as you move up into Maine, there's potential. We do see ensemble members take in this storm there. Again, this is still time to see how this evolves. The intensity is going to be dictated by the environment, and the environment's going to dictate, the intensity. And those things feed back to each other, and that can all change the track of a particular tropical cyclone as it moves forward. Before, I realized I didn't show where everything is right now, so let me realign ourselves, go back to the National Hurricane Center, and show all the storms here that's going on. Here's Sally over the southeastern U.S. Paulette has just became a post-tropical cyclone. This is breaking news. I just saw this now. I was looking at this literally 20 minutes ago, and it was still a storm. So Paulette has extratropically transitioned into a extratropical cyclone, and it's no longer a tropical origin. And here's Teddy. Teddy rapidly intensified overnight. It is now a Category 2 hurricane at 100-mile-per-hour winds, and the National Hurricane Center is predicting this storm to become a major hurricane and be yet another storm to impact Bermuda. We already saw the eye of Paulette move across Bermuda, and now it looks like Bermuda will see its second landfalling hurricane of the 2020 season. This is a rare instance. Bermuda doesn't typically get 2 landfalling hurricanes, guys. This is rare for Bermuda. We have seen it. We did see 2 landfalling storms, maybe 2 or 3 a few years back, but I don't think those were hurricane intensities. If the chat knows what those storms were, what those particular storm names were, please post it in there. But we're looking at our second potential hurricane landfall. The first one was Paulette as the eye passed over Bermuda. Now the second landfalling hurricane, there's risk here for Teddy. And if you look at the Weather Nerds page here, here's Bermuda and this little black dot here, and you can see how there's a lot of L's and spread. The spread's pretty large from north to south, but not a lot of spread west to east, right? With Teddy, but this is a potential devastating blow for Bermuda. I'm seeing a lot of these mean stellar pressures in the 950s and some of them even to the 920s. Guys, that's a very deep deep low pressure system, a very strong hurricane pressure wise. And we're seeing that, whenever you have a low pressure, like a low pressure in the 920s and 930s, the wind speeds are by definition going to be very, very strong because of the pressure gradient that develops between the minimum central low pressure of the hurricane itself with its environment, its surrounding environment. So, but this could be a potential devastating blow for the Bermuda island, and that's very sad to see, guys. Now, as we move forward with the storm, right? Let's talk about where Teddy might end up, and this is where we rely on ensemble models to take a look at these things, right? Because we have uncertainty. Our weather models have higher errors as they move out further in time. So in order to try to understand what the uncertainty is in a particular track of a particular cyclone, that's why we look at these ensemble products. And you can see that the track could be anywhere from off the coast of Cape Cod all the way through maybe the western northern Atlantic there. So the most likely track, though, right now at this point looks to be aimed east of Maine, northeast of Maine to parts of eastern and southeastern Canada there. So in those maritime regions there. So there is still a risk that Maine may be struck here. It's not a zero threat, right? We do see a number of low pressures that take in the storm right off the coast of Massachusetts, and then there's some right into Maine there. But the bulk statistics support a track east or northeast of the U.S., and I think Canada will have to pay attention to here if you guys are living in Nova Scotia or some of those other islands out there. So those are things that you're going to have to pay attention to. And we're looking out. I mean, this is a forecast out 192 hours, guys. There is still going to be some things that change here in the track of this predicted storm, but that's something that we'll have to keep an eye on. This looks like it's going to be the main feature after Sally fizzles out here, and Paulette's already a post-tropical storm. So this Teddy looks to be a major hurricane, and it's likely going to take a northwesterly track. And as we pay attention to this, we're going to have to pay attention to how the models handle the extratropical pattern, where the ridges and troughs end up over the U.S., over the North Atlantic, because that will all contribute to how this storm moves in the end. There's some other things that while we're here, we can point out. There is some kind of north to south moving disturbance here. It's probably some kind of extratropical cyclone or the remnants of Paulette. I'm going to have to pay attention. I can't really see in this particular plot because it's blocked here, but the National Hurricane Center is monitoring an area in the northeastern part of the subtropical Atlantic basin, giving it a low chance of development. But it's something that we'll have to keep an eye on. There's obviously something happening in the models here to pick up on the tracking algorithm. There's another easterly wave that's predicted to come off of Africa. The models haven't really been handling this that well. I remember a couple days ago, it didn't really show a whole lot, but there does look like there's a lot of track members pointing up here. This looks like it's going to be a weak storm, maybe a short-lived type of tropical storm, but this could be another storm here in the coming 6 to 10 days. And then there's also a disturbance over the western Gulf of Mexico that we're going to have to pay attention to, where we are seeing some models cluster here, a bunch of low-pressure systems out there, which could potentially push into the tropical storm realm. And I remember looking at yesterday's 12Z ECMWF high-res model, where we did see a potential tropical cyclone come close to the Texas border. So that's another thing that we're going to have to pay attention to. There are still 2 more storms on the horizon that we'll have to monitor. With 2 more storms left on the horizon, I feel pretty confident in saying we'll get our Wilfred storm in the next 7 to 10 days. And I do think that we have a shot to, obviously a pretty good shot of getting into the Greek alphabet here. Well, once we get one or both of these storms, right? We could be looking at a Wilfred and Alpha type of storm, type of event here in the coming week to 10 days. Hey, Ador, thanks for stopping by the stream, man. I appreciate it. Oh, you want to talk about the standing wave with the climatological Atlantic hurricanes, right? So, okay. Let me get into some more science here, guys, for a little bit while we have you on the stream. I'm going to head over to my playpen where I do a lot of the software engineering here to get some of these real-time diagnostics. This is not a public source, guys, so I apologize for that. This is a private internal thing that I've spun up here. But I want to take a look at some of the standing wave features here that Ador is asking about. And I can actually go to the CFS time longitude plot, low frequency Hobmar. Okay, let me zoom in here. All right, guys, so there's ways to identify how the atmosphere has coupled to pretty much like this low frequency variability in the oceans, right? Wherever you see like these purple, pink shading, this is essentially the atmosphere coupling to a very slow process in the ocean where you get these baroclinic circulations, essentially get low-level convergence, rising air, and upper-level divergence, right? This pink and blue shading is essentially representing air diverging aloft at the top of the troposphere near the stratosphere. And it's essentially this circulation that we're monitoring. This is the type of things you want to look for when you're making these seasonal predictions for either temperatures, we're interested in jet stream volatility, or even your hurricane seasons, right? When you have we call these standing waves. Essentially, these are a circulation cell that just stays there for a number of months in a row. And this set up back in, I think, the fall of last year, and has intensified or grown since the start of summer. And we're seeing this maximized over Africa and the Western Indian Ocean, indicated by those deeper pinks, right? This is a prime location for developing hurricanes over Atlantic. This is one of the main reasons why I was so bullish on the 2020 Atlantic hurricane season, because what happens here, when you have this particular state in the tropics at lower frequencies, meaning we're looking at things that vary very slowly in time, this is a prime state for African monsoon, the West African monsoon. This is a state that allows for enhanced low-level westerly winds, which are known as monsoonal surges across Africa, to be enhanced. And essentially what this also does is you have enhanced upper-level easterly flow across Africa and out over the tropical mean development region. These are really good states for reducing westerly vertical wind shear over the Western Atlantic. This is typically where we see the westerly shear. We actually climatologically see easterly wind shear over Africa and off into the main development region due to the West African monsoon. This actual low frequency pattern actually enhanced that easterly shear. And I think this is one of the reasons why we actually didn't see a ton of storms develop in the Cabo Verde region, right? In the main development region, we saw a lot of these storms push out over the Western MDR into the Caribbean and Gulf of Mexico and the Western subtropical Atlantic and intensify into these strong hurricanes. So I think this is one reason why, especially when you had these states of constructive interference, meaning when something is going to boost this low frequency standing wave, we have these boosting events happens by what's known as Madden-Julian oscillation events. Those are the waves in the tropics that can actually either enhance rainfall and circulation cells over the African Indian Ocean continent or suppress it. But when you have an active MJO move across the African Indian Ocean region, when there's a time of a standing wave, right, out there, which there is now, that is a time where we see constructive interference and we see a very deep explosion of convection, which then amplifies the circulation that can cause more shear over the eastern MDR. But this was the big signal that all the forecasters were latching on to this upcoming hurricane season, saying, "Hey guys, this is rare. This is not a state that's often we see." And we were on this for many months, right? If we look at a Hofmahler diagram of the same field now, but looking at a time longitude sense, right? The blue shading is essentially the same thing as what we're looking at, this blue and purples here. And we bring our eyes down this y-axis here. Essentially the y-axis is time. The x-axis is longitude. There's a mini map underneath it so you can see where you are in the world. The blue shading was all over the Indian Ocean African region since last October, November. And since then has only grown in amplitude. The big change from last season was the shift from blue shading over the Pacific to yellows and oranges. That's essentially the atmospheric coupling response to La Nina, where we see the suppression over the Pacific Ocean, but it also ties into this Indian Ocean standing wave. So you have rising air over the Indian Ocean, you have an area of suppression over the Pacific Ocean and over the South American continent. So this is the standing wave that Ador wanted to talk about. His question was, what is the impact of this wave? So For the hurricane season, we've already seen it. We've seen a record-setting pace so far this year, and it's been tied to these MJO amplification timeframes, right? We've seen, I put out a tweet actually. Let me go back on Twitter and go back to a tweet that I did this morning. I put too much out here. Sometimes it's hard to see, so I apologize for that. But here's a tweet I put out this morning looking at more MJO timescale variability. The black dash contours represent where the active MJO phase is. You can usually see the black dash contours overlie like the purple and blue shading, whereas the solid black contours are typically overlaying the like yellow and red shading. So the black dash contours is the active phase of the MJO. The reds, the solid black contours where you see the red shading, that's the suppressed phase of the MJO. We had an active MJO passage over the Atlantic African region between June 28th and let's say maybe around like July 18th, and then it slid across the Indian Ocean all the way through August 1st. This is a prime state for Atlantic hurricanes. That's also where the Indian Ocean standing wave is located. So when the active MJO moved across this region of the world, we saw deep purples, deep pinks. That is because your active MJO is amplifying your standing wave. That's constructive interference. Then we saw the suppressed phase come through probably around August 1st through the 17th there across the Atlantic and African region. And we saw these deep purples and pinks shut off, right? We actually saw maybe more yellows and oranges move into that part of the world. That's essentially, air is no longer diverging aloft, it's actually converging. So you have subsidence as that suppressed MJO moves across the area. So this is what we call destructive interference. Now we're moving into like the August 17th through to today, and we're seeing another, that same active MJO coming back around the Pacific, right? We could track it all the way from the Indian Ocean maritime continent across the Pacific and back across the Atlantic African continent and over the Indian Ocean through September 16th. We just had an active MJO passage, and now that was a correspondence to another uptick in activity for Atlantic hurricanes. So between June 28th and August 1st, that's when the first active MJO passage happened during summertime. We saw 5 named storms, 2 hurricanes. Then we had the suppressed MJO come through between August 1st and August 17th. We only had 2 named storms and no hurricanes. I remember as we moved into August, middle of half of August, there were a lot of folks, a lot of chatter, even in the professional tropical email servers that I'm on, saying what happened to the hurricane season. Everyone was calling for a major hurricane season, and there has been nothing through the middle half of August. 2 weak tropical storms, if that. What happened here, guys? Intraseasonal variability of the tropics plays games if you're trying to look under a seasonal microscope, right? You guys need to pay attention to what's going on here at the intraseasonal state, specifically these MJO passages during times of years where they're active, because this is when we were looking at these constructive interference events between the MJO and the Indian Ocean standing wave and the African standing wave. Those are the time frames where we saw the Atlantic hurricane season really pick up, right? Because after August 17th, when the next active MJO came through, August 18th through 16th, that is where we saw 9 named storms, 6 hurricanes, and 1 major hurricane so far, right? We're still seeing the active MJO over the Indian Ocean, and we're still expecting at least 1 more major hurricane Teddy. The National Hurricane Center has Teddy at a Category 4 intensity as it moves south, as it approaches the Bermuda region. So, if you look at this map, right, and you just follow the pattern, there's a chance here, guys, that we move into another intraseasonal lull in activity as the next suppressed MJO comes across the Atlantic Ocean in Africa here in the latter half of September. So, you obviously keep this pattern moving forward here as you move into like the latter half of October. That's where we could see another round of storm activity. And that, since late October is a time where African easterly waves start to turn off, the West African monsoon starts to turn off. And that's where we start to see storms develop closer to home, Caribbean Sea, Gulf of Mexico, subtropical Atlantic. Those are the areas that we're going to have to pay attention to. And I think that we're going to see another burst in activity here late in October. So once we get past Teddy, Wilfred, potentially Alpha, there could be another lull in activity. People might think the storm, we're done for the year. Don't be fooled, because we're going to have another MJO passage in the latter half of October, and there'll probably be more activity coming. And those are the storms that we're going to have to pay attention to again for landfalling storms, because we've seen the western part of the basin be the more preferable location for intensity of tropical cyclones. So I don't think it's going to change in October. I think we're going to have to pay attention to as the Gulf of Mexico ocean temperatures recharge, they start to warm out, mix out those cold ocean temperatures that we've seen come from the upwelling of Sally. That's where we're going to have to pay attention to again. All right, I see that we have another question. Jabron, I appreciate you coming into the stream here. You're quite surprised to see the Bermuda high break down so much after being so dominant in August. Yeah, so one thing that happened, if you look at a time series of the North Atlantic Oscillation, this is essentially a index that essentially measures, the heights over Greenland and the North Atlantic Ocean. Here, I'm bringing up, no, not that one. I gotta do teleconnections here and see where these guys are. All right, let me go down to the North Atlantic Oscillation here. Unfortunately, I don't have a long enough time series here, so I apologize for that. But what you could kind of see it here on this time series. For much of the month of August, we had blocking high pressure system over Greenland. This was causing a ton of upper level cyclones to dig across the northern subtropical Atlantic Ocean and cause what's known, or amplify a feature what's known as a tropical upper tropospheric tut. A tropical upper tropospheric trough. There we go. I was stumbling on my words there, guys. It's actually known as a tut. And these features can actually, depending on where they are, can actually amplify the subtropical ridge a bit further south than it typically is. And we saw that, and then we saw a ton of strong trade flow over the main development region. We saw a lot of upper level easterly shear out there. I think the North Atlantic pattern had a role on the subtropical high in August. But since then, as we move into September, we saw a flip in the Greenland pattern, where we saw a trough dig down across Greenland, and we observed the North Atlantic pattern change in a way that is consistent to a positive North Atlantic oscillation, where you can see these positive values now for much of the month of September. And that actually resulted in the subtropical Atlantic high to move a little bit further northward compared to its climatological position. And I think this allowed for more of these main developing systems coming off Africa and allowing to break out, move into the central part of the basin and kind of, create its own environment, right? We saw this happen with Paulette. Paulette broke pretty much the pattern there across the central subtropical Atlantic, and we haven't seen it really shift back. So when we were looking at North Atlantic, MDR tropical cyclone activity, we have to pay attention to the extratropical pattern, because when we get these shifts in the North Atlantic pattern, it can actually change your activity over the tropical Atlantic basin to be something else that we haven't seen yet. And I think that's what happened this year, right? We didn't have a lot of MDR systems for August. September, we're starting to see all those storms happen. Yes, it coincides with the peak of hurricane season, climatologically speaking, but it also coincided with a major transition in the pattern over the North Atlantic. All right, I see Budget has a question here. How many years have we got into the Greek alphabet? That's a great question. So I was looking at when the last time we had 20 named storms, and I think it was 2011. 20 named storms is not yet the Greek alphabet. 2005 was the last year that I can remember off the top of my head where we busted into the Greek alphabet, right? That was a famous hurricane season. I think 2020 is going to be another famous hurricane season. It already is. So, but I'm not entirely sure. You know what? I'm gonna ask on a lifeline here on my Twitter to reach out to Phil Klotzbach, the master of tropical statistics, and I'm gonna put out a tweet and ask him how many times have we seen the North Atlantic hurricane season get into the Greek alphabet. So that's something that I'm going to have to reach out there for a lifeline. So I see Van. Thanks for joining the stream, Van. With La Nina, do you see any more activity in the Atlantic and MDR after this wave coming off now or no? Well, okay, so going back to that tweet that I did on the MJO, right? We have a suppressed MJO phase moving across the Atlantic basin, and it's moving across Africa. This is going to cause some interference with the standing wave out there. So once this next wave comes off Africa, maybe it develops into Wilford, maybe it develops into Alpha. I'm not seeing a tremendously amount of favorable environment over the Atlantic or Africa for future MDR storms. But there still is negative VP200 anomalies, the blue shading over Africa as we go into the latter half of September. So it's not impossible. I'm just not seeing what we just saw with this major MJO passage, right? I'm not seeing that type of enhancement to the West African monsoon that gets me excited for future MDR storms. It's still possible, though. I'm not seeing a full yet swap over in velocity potential to positive anomalies with the suppressed MJO coming through, but I'm still not seeing that, like, whoa, there's a big signal coming in, and I think we're going to have to pay attention for more waves. That has passed now. But I'm not super bullish there. Hey, what's up, Renee? Thanks for coming to the stream. I appreciate the tornado emojis there. Thanks for stopping by. Ador, I see you have another question here. How was the hurricane season until now from your point of view? It was a record-setting event. It was a record-setting pace. We've seen 8 landfalling tropical cyclones over the U.S., the continental U.S., guys. That is a record to date. It's September 16th. We had 8 tropical cyclones form. Let me go back through that list of names of storms, right? Bertha, Cristobal, Faye, Hannah, Isaias, Laura, Marco, and now Sally. Those are the 8 tropical cyclones that has made landfall across the U.S. to date. It has beaten the record set back in 1916 for the number of storms that has made landfall to date through this point in time. 1916 was the all-time record high landfalling number of storms for the U.S., the continental U.S., with 9. So we're one more storm away from breaking or tying the all-time record for number of landfalling storms. There's a chance that we do it with that Gulf of Mexico system, but I don't think that... actually, there's still a chance with Teddy. I'm a little bit less optimistic on that with regards to another landfalling storm from Teddy, but it's not out of the cards right now for northern New England there. I appreciate everyone. Thanks, Kim, for finding value here in the stream. I enjoy being able to come out here and talk with you guys. I know we're getting to the top of the hour here, so I know that we're getting close to the end here, but it seems like the stream didn't lag out, so I appreciate that. This new platform might be a winner here for moving forward. Okay, so crazy. Yeah, the only other time that we had 2005 since the new naming convention began in the mid-1900s, that's the only time we have gotten to the Greek alphabet was 2005. So, guys, 2020 and 2005, we're going to have similarities. There are differences, right? 2005 had a lot more major hurricanes this date, but the number of storms that happened to 2020 so far, it's in the ballpark of 2005. And the storms we're seeing now, these are not low quality storms, right? We had 3 Category 2 hurricanes this morning active over the basin before Paulette became a post-tropical cyclone, and we're still looking at another major hurricane possible over the central Atlantic. So, while there are similarities to 2005, there still are differences, but we are still seeing a crazy amount of storms over the Atlantic basin, and we've seen 8 of them make landfall in the U.S., which is absolutely crazy. Budget, I've switched over to the OBS streaming platform. I was messing around with Twitch Studio, but it seemed like there was a lot more lag coming from Twitch Studio. So I did switch over to OBS, and it seems like it's being a bit more friendlier for the stream today. So I'm happy about that. We need this type of video full years. I'm not sure what you mean by this type of video there, Ador, but if it means getting, this Twitch stream out throughout the year, that's something that I will be doing, guys. I might do it a little bit less of a pace here, but I'm still kind of debating that. I'm a big winter weather weenie, right? I like talking about winter weather. There's a lot of interesting things that happen: tropical, extratropical interactions, stratospheric, tropospheric interactions. There's a lot of good guests that I plan on bringing onto the stream, guys. That we can learn from, and people that are in academia doing teaching this stuff to students. There's gonna be some professors coming on the stream. We're gonna have Eric Blake from the National Hurricane Center come on after the hurricane season's done. Actually, I'm gonna give him some time to take a breather. I know he probably needs a vacation from all the work he's been doing. But I plan on having him on at some time, telling everyone his experiences during the season, the amount of work that's required, the amount of stress that you're under as a forecaster who are dealing with life and property. So those are all guys that will be coming to the stream throughout the upcoming months here. So thanks, guys. We're at the top of the hour here. I got to get back to a bunch of computer coding. I appreciate everyone coming in. Thanks, guys. It's been fun. Thanks for everyone who's subscribed. Thanks for everyone who has followed me and participated in the chat. We'll start this up next week again, guys, and we'll continue with this platform. Thanks so much, guys, and we'll talk to you then.